Logarithmic functions are pretty funky things. So just like when we were graphing them, we wanted to take our log functions and change them into exponentials. We're going to do the same thing when we're solving for these log equations. So we can take these log equations and change them into exponential form, and then we're able to solve them a little bit easier. So jumping right into this lesson is connected to the evaluating logarithmic functions. Hopefully we're able to do the either down and diagonal or changing them to exponential form. So starting us off, let's take log base 3 of 4x minus 7 equals 2. Long story short, we need to solve for x. Okay, in the end, we're going to have an answer of x equals some number. So previously, we've looked at, in order to get rid of this log, you could raise both sides to that base number. So if I take this whole side and raise it to the third power, what I do to one side, I have to do the other. So basically, this 3 and this log cancel each other out, and we get 4x minus 7 equals, and then 3 squared is 9. And now look at that. That's a much easier, I guess, to solve equation now. So we would add 7 to both sides. So 4x equals 16, and then in the end, x equals 4. And there's our answer. Now another way you might have seen it, and I'll go through this real quickly, if we had log base 3, 4x minus 7 equals 2. Another way you might have heard this previously is down and diagonal. Okay, down and diagonal. I always have trouble with that. Down and diagonal, where the base comes down, the exponent comes over, there's your diagonal, and then this part diagonals to the other side of the equal sign, 4x minus 7, and basically that creates the same equation as before, where 9 equals 4x minus 7. So whatever you're more comfortable with, whether it's down and diagonal or just raising it to that base exponent, either way, problem comes out the same. So let's take a look at another one. Let's go log, log base x, 64 equals 2. Now what's really weird about this, there is an x, but that x is located as the base this time. So again, you can either take that base and put that whole thing to that base exponent, but what you do to one side, you do the other. Those x's cancel with the log, so 64 equals x squared, and you get rid of squared by square rooting. So x equals, now in the past we did plus or minus. In these problems, we're just going to go with positive. Okay, we're just going to go with positive, or at least for this answer, because a little note to make right here, and I'm trying to pull up a new pen. All right, so if you look right here, this x that we're solving for is the base, and bases are always, always positive. So if you're solving for the base, you have to make sure the base is always going to be positive. Now, if it's some other situation that we run into, we might need the plus or minus, but in this case, we were solving for the base, and bases can only be positive. All right, so x equals 8 is my only answer on this one. So let's see if I can pull up another example of this. So these move pretty quickly once we get past that first step. All right. Let's go ahead and take log base x 1 over 8 equals 2. So we could raise this whole thing to the base, which is x, or we can do down and diagonal. I'll go down and diagonal this time. So x comes down, the 2 comes over and becomes the exponent, and then the 1/8 goes to the other side. All right, to get rid of the exponent 2, you need a square root. So I get x. But what I do to one side, I do to the other. Now, square rooting a fraction, a little funky here. If you want, you can split it up. You can square root the top. You can square root the bottom, because that's really what you're doing here. So Square root of 1 is 1. Square root of 8 doesn't really break down, but it does come out to a 2 square root 2. And you have a couple options. If you want to rationalize that, you can. Right now, we're just really trying to find out what x is equal to. And remember, that x was the base, so it has to be the positive when we square root it, no negative. All right. I'll throw in another one here. Let's go log base 3, 3x minus 2 equals 2. This time x is not the base number, it's hidden in here, but we do the same process. You can either down and diagonal, you can raise stuff to the base. I'm more familiar with down and diagonal, but it comes out the same. So 3 is there, 2 becomes the exponent. That whole parentheses piece moves to the other side. 3 squared is 9. 3x minus 2. Next step would be add 2. So you get a 11 over here equals 3x. Or in the end, when you divide by 3, you get 11 over 3. All right. Now, one last special case that we're going to look at here. One last special case. Let me find the page. Let's say we had e to the 2x equals 5. All right. So you may be saying, why are there 2 letters in this one? But just like before, we want to solve for x. E is actually a value, and it's a number on your calculator. It's a button on your calculator, and we're going to use that in a second. Basically, when they're talking about e has an inverse, and it's called ln. It's the natural log. Now, if I ln times e, that's the same as log base 10. So, what we're talking about here is, long story short, because you really don't want to hear all the theory behind it most likely, anytime I see an e, the opposite of that is going to be the ln value. So just go ahead and put an ln next to the e. But what I do to one side, I have to do the other. So ln and e cancel each other out. That leaves me with 2x on this side. On the right hand side, I still have ln 5. And if you notice, you look on your calculator, there is an ln button. It should be nearby your log. So if you're on the graphing calculator, it's right under log. So go ahead and just plug that into the calculator, ln of 5. You should come out with a decimal. So ln of 5, we get a 1.609. X equals, go ahead and divide both sides by 2. 0.805, depending on how they want you to round it. Okay. I mean, another acceptable answer, if you go from here, you could have x equals ln 5 over 2, which is just kind of the unfinished version of that. So let's see another one of those just real quick. So basically, anytime you see an e, just go ahead and slap an ln on in front of it, and you're good to go. All right. So let's say we have e to the negative 2x plus 1. All of that's the exponent up there. Equals 13. The x is locked up in the exponent. I need to bring it down. The e is keeping it up there. We get rid of e by introducing an ln. ln cancels e. But what I do to one side, I do the other. So now the negative 2x plus 1 drops down. ln 13 is still over here. We're going to go the non-decimal route this time. So let's just go ahead and move numbers over. So negative 2x, and then subtract the 1. So we have ln of 13 minus 1. And still, you can put this stuff in your calculator. And finally, dividing both sides by negative 2. What I do to one side, I do the whole other side. So x equals ln of 13 minus 1 over negative 2. X is by itself. Good to go.